Hello everyone, this is Revati, working as an assistant professor in the Department of Artificial Intelligence and Data Science. In our today's video, we are going to see about an important topic on data structure. Before moving to the particular topic, we have to know about what are the data structures are using in our day-to-day life and what is the purpose of those data structures in our life. Then we will move on to the real-time example. The ADT stands for Abstract Data Type. It is a logical model that defines what operations can be performed on data without explaining how those operations are implemented internally. Think about driving a car. You know how to start and how to move and how to give brake, but you don't know how the engine works internally. Similarly, an ADT tells us what operations are available but hides the implementation details from the user. This concept is called as abstraction. Next is the components of ADT. Every ADT consists of two parts. That means the first part will be data and the second part will be the operations. The data is nothing but what are all the information stored in the database. The second is operations. These are functions performed on the data. For example, in a stack ADT, the operations are push, pop, pick, is empty and is full. These operations defines the behavior of the stack. Next, let's we see the comparison between the ADTs and the data structure. Many students confuse ADT with data structure. Yes, let's understand the difference between the both of the ADT and data structure. An ADT tells us what operations should be performed on data. A data structure tells us how those operations are implemented. For example, stack is an ADT, but it can implemented using arrays and linked list. So ADT is the logical view of data and the data structure is the physical implementation of the data. Uh, Next we will see the common types of ADT. Some commonly used ADTs are list, stack, queue, tree, graph, and dictionaries. Among these stack follows LIFO, that means last in, first out. The queue follows first in, first out, which means the first inserted data will be processed first. For example, consider a stack, browser back button, undo operations and function calls. In this situation, the stack concept will be applied for the data. Then next we will consider the queue. For example, you are going to print a document, means you can just give the print to the printer. Again you need to print another document, means at the same time you can give the print option, but the first print document will be placed in a queue. It will be served first. Then the next one is CP scheduling. Then next is ticket booking system. Next we will see about the advantages of ADTs. Uh, why do programmers use ADTs? Because they provide abstraction, code reusability, easy debugging, better security, independent implementation. However, there are a few disadvantages. Designing an ADT requires careful planning. Beginners may find them difficult initially. Let's we move to the in this slide, we will see about the applications of ADT. And the ADT will be applied in database systems for storing data, and it will also useful in the operating system in CPU scheduling, then compiler design, and it will also useful in the artificial intelligence. Then it is used in networking, and it is also applied in the software development. The next is the let's see conclude this. ADT provides abstraction and modularity to the user. It specifies operations without revealing the internal process to the user. Then next is a fundamental concept in data structures and software engineering. The common ADTs includes stack, queue, list, tree, and a graph. In my upcoming videos, we can see these ADTs in detailed manner. Thank you for watching.